Hello everybody, and welcome to Houdini to Maya CD color data. In this tutorial, we will learn how to transfer color data, that's the CD attribute, from Houdini to Maya. We'll export the geometry out of Houdini into an Alembic format and import the geometry into Maya. In addition, we will show methods how to render shaders using the color data values in these render engines: Arnold, V-Ray, RenderMan, and Redshift. This is my GitHub page, and in the tutorial assets, I have the vex that we will be using for our attribute wrangles in Houdini. In addition, if you want to download all of the assets used, I provided a link here, a zip file in which you can download. In addition, here's a reference page. This page is where I got some of the vex code that we will be using in order to transfer the color data from Houdini into Maya. Okay, let's meet in the dojo and begin training.
Before we begin, remember, may the horse be with you.
Okay, here I am in Houdini version 21. Let's build some quick geometry to export from Houdini into Maya. I'm going to drop in a pig head, dive into the geometry. Now I'm going to transform this. I'm going to scale it up and make it big and drop in a copy to points. The target is going to be the pig head, and the geometry to copy, let's create a torus. Drop that into here. If we view the copy to points, now we see all of our toruses copied onto the pig head. Now with copy to points, we can pack an instance. Now the first thing that we need to know when transferring the color data, we should not pack an instance because the color data is based on our vertex points. If we view here our points, we can see that each point is referencing the torus. But for the color data, we need full geometry because the color data is going to transfer for each of these points for each individual object. Let's check it and we can unpack it later. Okay, let's create a class node for each of our toruses, and we're going to drop down a connectivity. And for the attribute class, we'll leave it just that, but let's turn it into primitive. What that'll do is in the geometry spreadsheet here in primitives, we now have a class for each of our primitives. Now next we're going to write some vex code. So let's add an attribute wrangle, 2 wrangles. Now in this wrangle, we're going to write the code that's going to allow Maya to read in our individual geometries. So to make it easy, I put the vex code here on my GitHub page where I can copy and paste. And if we view that now, going to the geometry spreadsheet under points, we now see that we have a path. Notice it says instance 0 for all of them. We want to take this path out of points and put it into primitives. On the attribute wrangle, click on run over and let's do primitives. And now what we have, a geometry in Maya for each of these primitives. That's for the Maya part. And now let's generate some random colors. I'm in Maya really quick to show what we're going to do. So if I control tab, I'm using the Cosmos plugin and I type in cube, put a polygon cube. What we're going to do, if I click on mesh display here in the color set editor, you can see that there's no color sets. We want to bring in our color set data, that's our CD data from Houdini, and put it into our color sets. And we will do that by using the CD values. We can have multiple CD values or just one. Okay, I'm going to view my attribute wrangle. So this first line, we want to have a seed value, and that's going to be ptnum. Next, we want to get a random value from the seed. I'm going to hit enter a couple times to get multiple lines, and this is just going to generate a random value and normalize it from 0 to 100. So now we have a value. Now if I set the vertex value of CD and set that to val 100 and go into the geometry spreadsheet under points, we can see our values here. Now notice what'll happen if we set the value to 1. Well, that's going to target everything. Notice the values go from dark to light. What we're going to do is create a mask value for each of the ranges. We're going to have 4 CD values, but let's just start off with 1. So I'm going to create a mask. The value is greater than or equal to 0 and less than 100. We're going to set it to 1, if not 0. Then we're going to normalize those values. I'll change that to 100 again, 100, 100, 100. 100. So this is going to be everything. For the CD value, I'm just going to do this, and that's going to turn everything black. But when I click create spare parameters, it's going to create this color ramp. Now we can't bring these values yet into Maya because we have to make CD attribute a color for export. If I control middle click attribute wrangle here, you see this CD value. It's a 3-fit. This is very important. Your CD value has to have color. So if I create another value and say v at CD2 and I middle click, you can see CD2 is not a color value. CD is Houdini's standard value for color, but if I created another CD value, it does not have color. Any additional parameters that we wish to bring into Maya that has a color, we have to use the set attribute type info function. And if I use that, I set it CD2 and make that into a color value. Now when I middle click, you can see CD2 is a color, but I'm going to comment these out for now and just show you what it looks like if we just import these colors right now into Maya. Also, as a side note, you can drag this slider up, that'll make everything white, or you can drag this point down and that'll make everything black. But for good random values, which is what we wanted, we can use this ramp for now. Let's use the attribute promote, and we're going to promote our CD value from point into vertex. This is very important. These cannot be points. Maya is going to read the vertex values. So if we view that and we go into our attribute spreadsheet, we can see now that our colors are now in our vertices rather than our points. If we turn that off, our color values are in the points, but if we turn it back on, they are now in our vertices. And this is exactly what we need. Now we need to unpack because we need to import each individual vertice. If I turn that off, you can see that we only have 879 points here total, but what we need, turn that back on, is we need to import all of our points. So I like to do the unpack last. It just allows me to have a better workflow. But notice if I middle click, none of our attributes transferred over. Our CD value didn't transfer over. So if we hit transfer values and hit CD and then view unpack, now we have our vertex attribute color. Make sure this says color, and then let's do the Alembic ROP output. I'm going to save my HIP file as color data, and I'm just going to save this color data.abc for Alembic. For the hierarchy, let's build hierarchy from attribute, and let's have our path attribute, which is the attribute we set here in the attribute wrangle, string.path, and it's here in our geometry, the path. For our geometry, we have each of the individual geometries. Perfect. Okay, let's save to disk and let's head over to Maya and see what happens. Here I am in Maya. I'm going to go up to cache, Alembic cache, reference Alembic, and import the color data. And look, Maya does read in the color data, but it's one object. If we wanted the individual objects, what we would have to do in the unpack is transfer our class and our path. And notice what that did here in our geometry. So if I save to disk, go into Maya again, if I click file and then come here to reference editor, we can see our reference here. I'm going to right click and just go to reload reference. And what that's going to do is it's going to reload it, but now I have each individual object. But for now, let's just transfer our CD, save to disk, come back in here and click reload. So now we just have one object and we can move it around. Now let's do Arnold render. If I click on Arnold, if I go to render settings here, I'm going to switch my render to Arnold render, and then I'm going to click on IPR. Now nothing's happened because I need to add a light. So let's go to Arnold lights. Let's just add a sky dome light. Now, as we can see here in the render, it's gray. Our colors don't transfer over. However, if we go to mesh display, color set editor, and we select our geometry, this is what we need to see. Make sure our CD value, the color data value, transferred over. That's because we transfer our attribute CD. Now, in order to get this to render out our individual colors, let's build that shader network. Again, make sure this has CD there under color set editor. This just confirms that the value did get transferred over. Okay, I'm just going to put this down here. I'm going to make this view a little smaller, adjust that. What I like to do is go to settings and preferences, hotkey editor, and I like to set the hypershade view to the letter H hotkey. This way I can just hit the letter H and it'll open up my hypershade window. Now this step is important. Let's bring in an Arnold shader. We can just drop in an AI standard surface and let's assign that. Right click, assign to selection. Okay, just had to refresh so we can see the color change values here. I can change the value to something like yellow or just back to white, middle gray, whatever. Now, if we want our color set data value, CD, to transfer over into our shader, we can bring in AI user color data. This is only for Arnold. AI user data color. I can middle mouse drag this onto color, or I could drag that into color. And now it turns black. Now this is an additional step that we only need for Arnold and RenderMan. For V-Ray and for Redshift, we don't need this additional step. And this applies if you have multiple geometries. You need to click on geometry, come in here to the mesh. Under Arnold, we need to check mark this export render colors. And I stop the IPR, start it again. For our attribute value, we need to put CD for our AI user color data. I'll stop the render and restart it. I'll close the render view and Arnold render. And once we do that, we see our color data is now transferred over. And this is exactly what we want. Now let's stop that, close the window, and let's bring in multiple values. Another way to edit vertex colors for multiple geometries is we go to Window, General Editors, Attribute Spreadsheet. This will bring up a spreadsheet. And if we click the Arnold tab, you see here AI export colors. So for example, let's just say that we wanted to transfer our path and class values again. Save to disk, come in here, reload. Well, this value needs to be set on each individual one. So instead of clicking each individual one, checkbox here, click that one, checkbox here, what we can do is we can select all of our geometry like here, and then click on export colors and just type in 1, and then that'll set it for each and every one. Okay, just exporting the CD value, coming back into Maya. Okay, Maya froze, so I will show you how to do this very quickly. We go to cache, Alembic, reference Alembic, bring in our color data. I'm going to go into the mesh and Arnold, check export vertex colors. In my hypershade, I'm going to create a standard surface. AI user data color, CD, drop that and connect that into the base color. Assign this material, add a light, Arnold, lights, physical sky. Okay, our values transferred over. For our sky, I'm just going to increase the intensity a little bit. In my original tutorial where I showed how to export the geometry into Maya, there was a comment left here at the bottom that says, it's very good for me. I have one question. If an object has many colors, like confetti, I want to use different colors of the object in Maya. How do I do that? And then I said, I'm going to make a tutorial on this and I need more training, which I did take more training. And let's show you how to do that now. So here back in Houdini, let's drop in an attribute randomize. Now, if I view that in the Scene Explorer, it's going to automatically randomize the CD value, which is what we want. We can bring all these colors now into Maya, save to disk. In Maya, if I reload the reference, now our color values got transferred over. Now let me show you how to do multiple CD values. So here in our attribute wrangle, I'm going to create multiple CD values. All these steps aren't necessary. This wrangle isn't necessary at all, but I just built this wrangle to easily show how I can build different CD values and have the attributes randomize and color so that when I bring them into Maya, I can show this project off. So I'm going to copy and paste my final code here and just briefly explain what that does. It's going to assign random values to random objects. So what I'm doing is I'm creating a mask. It's saying from between 0 and 25. This is going to be CD. And then for CD2, it's going to be from 25 to 50, 50 to 75, 75 to 100. And then I'm just going to normalize. I'm going to fit that and map it from 0 to 1. I'm going to fit the values, each the one from 0 to 25, 25 to 50, 50 to 75, 75 to 100. It's going to fit it. And we can see our CD values, CD, CD2, CD3, and CD4. And then I'm going to multiply our mask by the floor. And then here, it's just going to use the ramp to map random color values. And then here I have this for export. Now, if I control middle mouse, you see here that all my CD values have a color tag next to it. That's very important. If I took this line off, only the CD value has a color tag. The others don't. That's very important. They all need to have a color attribute type. Now, this is showing CD in the viewport here. If I wanted to, I could make this slider go up, and that'll turn everything white rather than to have it transition from gray to white. I'm going to put this up so that they're either going to be white or black. And then for the attribute randomize, for only CD, I'm going to have it randomize the colors. So I'll have colors for CD, and CD 2, 3, and 4 will just be black or white. I'm going to do an export here, save to disk, save my file, come back into Maya. I'll close Arnold. I will reload. If I open up the Arnold render view, it's going to render CD. But now if I select my object and go to Mesh Display Color Set Editor, you see I have my CD value here, but I don't have any of the other values. That's because in Houdini, if I go to Attribute Promote, I need to promote all the other values, CD2, CD3, and CD4. For the unpack, I'm going to transfer those values again, CD2, CD3, and CD4. Very important step, save to disk. Back in Maya, I'm going to reload the reference, and if I go to Mesh Display Color Set Editor, oh, it didn't transfer CD4. I wonder why. Aha, typo. CD4, make sure that's CD4, yep, still training. Hiya! Now if I reload, go into Mesh Display Color Set Editor, now all the values transferred over. Now if we wanted to see that, if I just assign this your Lambert color, and then I went to CD2, you can see that now changed, CD3, CD4. So all the values transferred over, which is great. This is exactly what we wanted. Make sure you assign your standard Lambert color if you wanted to see the colors in the viewport. But because we want to render this with Arnold, I'm going to right click, assign to viewport. Then when I hit Arnold render, you can see this transferred very, very well. Now, if I wanted to see the other CD values, well, that's self-explanatory. We come into the user data color, and in the attribute editor, we just change this to CD2, CD3, or CD4. Brilliant. Now we just viewed how to do that in Arnold. Let's see how we can do that in V-Ray, RenderMan, and Redshift. Next, let's do RenderMan. Okay, I'm going to clear out everything, and I'm going to switch everything over to RenderMan. I'm going to hide my dome light in Plugin Manager. For now, I'm just going to load everything. I'm going to load Redshift, V-Ray, and RenderMan. So there's Redshift. Let's load RenderMan for Maya. Looks like V-Ray is already loaded. RenderMan for Maya. Now for render settings, you see I have all my renderers here. Let's render using RenderMan. For RenderMan, let's create a light. I'm going to go to create lights, and I'm going to create a dome light. Okay, let's just do a regular Pixar standard surface, and it's the same thing as we did for Arnold. We need to have Pixar attribute. Okay, we can either use a Pixar attribute or a Pixar primvar, and just to test that that works, for the Pixar attribute, in the variable name, we can put CD, and same thing, CD, but for the variable type, make sure it's set to color, variable type, color, and for the Pixar surface, we can just drop that in there, and we can assign our Pixar surface, and when we do that, it actually does change that, and just to show that that is working with the primvar, we can also do the out RGB, and it does work either one. So these are the two you can use, the Pixar attribute, Pixar primvar. Now we want to render using RenderMan, so let's go to RenderMan, or let's just click the IPR render. What that's going to do is it's going to open up the IT render view. Now everything's black, and that's because what we need to do is same thing as Arnold. We need to come in here into our mesh under RenderMan. We have to scroll down here, and we have to check this option, emit color sets. When we do that, come back into the it render, and here it transfers over perfect. And that's how to do that. And so this setup right here, that's how to do that using RenderMan. Again, for the attribute spreadsheet, we can go to Window, General Editor, Attribute Spreadsheet, and we can just go to the RenderMan, and here it says output color sets. Make sure that's on for each of your objects. We can change that to CD2, and again, we can see here, this is working out as we have expected. Okay, let's check out Redshift. Well, we could use the Redshift render view, but I don't have a license for Redshift. I can't show what the render will look like, but I can show you the setup. So let's hide the dome, clear our graph, add in a Redshift standard material. What we want is Redshift user color data. Same thing, we come in here and we can type CD. We'll assign this Redshift material. We can add a dome light. Nothing displays in the viewport for Redshift, but then we can go user data and output that to the diffuse color. And here in the user data, we can type in our CD values here. That's our setup for Redshift. Let's finalize with V-Ray. I'm going to hide the dome light for Redshift. I'm going to add a light dome light for V-Ray. V-Ray. I'm going to switch my render over to V-Ray. I'm going to create a V-Ray material. Let's clear that V-Ray material. I'm going to assign it to the viewport selection. Now for V-Ray utilities, we have the V-Ray user color. We can drag that onto diffuse color and make sure that we did assign that. Good. If we start our IPR, you see nothing happens, but the moment we come into the user data and we type in CD, we can see our values transferred over in V-Ray. And there's no additional steps for V-Ray. Again, we can view the color data 2, the color data 3, the color data 4, or just the color data. And that's how to set this up using V-Ray. After training in the dojo for some time, I wanted to figure out how we can use color data to create masks so that we could apply different shaders and textures to this object using different masks, such as white and black. So here in Houdini, you see here we have white and black. So the white could be a different texture than the black as sort of like a mask. So here's how we could do that in Maya. So let's bring this over. Here in the Hypershade window, I'm going to change the user color data to CD2. And now we have a white and black. We can have a different texture and shader. So let's build that really quick. I know that in V-Ray, we have V-Ray blend material, and we could add 2. So let's build 2 different materials. Let's add 2 materials. The first material we could be green. Maybe let's just do like a cool green like that. And then another material, maybe just like a yellow or maybe a red, something like that. Now in our blend material, let's drag each of them over. Let's have the red go into coat. We leave the base material blank. And for the green, we can assign that there. And then we will assign our object the V-Ray blend material. Now that doesn't do anything right now. And all we need to do is take our V-Ray user color node, which is set to CD2, and drag that into the blend amount for one of these. So we can drag that into the blend amount for the first one, and that'll create sort of like a semi-transparent, but if we turn the blend amount, if we do all the way down, that'll just get rid of it. And I will use invisible, and here we have sort of like a masked version of that in our blend material. If we turn it all the way up, you see, well, now it's just green. If we drop the user color data into the blend amount there and get rid of that and turn that up, now you see we get both colors, which is pretty cool. I could add another user data and have this set as CD3, go into the V-Ray blend material and drop that in there. And now you see we have only the red, the green, and you guessed it, if we do CD4, copy this material, turn it into like a bluish, add a new item, drop that into the coat. Again, we can turn that down or turn that up, but once we drop in our user color, now we have the blue. And there are some missing, so in order to see those, okay, and here's the setup. Let's take all the settings down and show what we did. So if we went to materials and we signed it our V-Ray material, you can see it's that color right now. Now here in my blend material, I have the base color set to V-Ray blend material 1. This currently has the diffuse color with CD. These other materials don't have diffuse colors set because we're going to set them in the V-Ray blend material. So here for the coat materials, I've assigned V-Ray 2, that's green, 3, red, 4, blue. And for the blend amounts, the corresponding utility nodes, the color data. So this one, CD, is assigned to the shader in base material under the diffuse color. But then for the other user color datas, I'm using that as the blend amount because these are black and white values. The CD value is the color values, the randomized color values. And for the CD 2, 3, and 4, those are the black and white values that we defined in Houdini. Now for the base material, if I turn the opacity down, we can't see anything. Going into the blend material, if I turn this value up and then I assign the surface and I assign the blend material, now this only shows the green. So we can make this material whatever we want. In swatch properties, we can have a preset, and let's just say we want to replace the green with some glass or maybe a ceramic, or we can build our own material. Chrome, let's do plastic. Let's do plastic, and then we could maybe change the color to like a green plastic. We can make it very reflective. We can add some metalness to it. We can build whatever kind of material we want to, and we can put it into the V-Ray blend material. We can just turn the opacity up or down, or turn the opacity up for that one, and that's the red. Turn the opacity up, that's the blue. Now each one of these have their own alpha channels. So you can see as I turn up the opacity, now the alpha channels start to come in, and here's the blue, and then here's the green. For the base material, this one has the CD value attached to the color. If we turn the opacity up, now they start to come into play. Now you can't really tell, but if we go into the alpha channel and we bring up and we slowly start to bring this up, you can see that they slowly start to come in. If we go into the blend material and turn all these down, well then we have our full base material, and we turn these up, and we can do this in V-Ray, we can do this in RenderMan, we can do this in Redshift, and we can do this in Arnold. Okay, and there you have it. What we learned in this lesson is we learned how to bring in our CD values from Houdini into Maya. In Houdini, we added some Vex code just to randomize the different colors and show how if you do have additional color values, you need to set the attribute type for each color value other than CD to color, so that here when you view in the attributes, you need to make sure that all your CD values that you wish to transfer over have an attribute type, in this case color. Then we promote the points into vertex, because in order to read color data in Maya, they need to be vertex. If we do unpack, we transfer all the values. If we want individual objects, just make sure you transfer the path and the class. Then we exported building the hierarchy for path. Over in Maya, we can either import it as a single object or multiple objects. We learned how to set up the color data values for V-Ray, Redshift, Pixar RenderMan, and Arnold, and showed how to correctly view the color data. In addition to the color data, we learned how we can apply masks so that we could add different shaders to different color values using the black and white values that we made in Houdini. Well, I sincerely hope that you enjoyed this lesson and can take away something from this tutorial. It was a little technical, but I know that this kind of situation you will no doubt encounter sometime in the future. Hope to see you soon, and
Live long and prosper.